Samsung's semiconductor project in Texas started as a standard expansion plan, but turned into a far more complex and expensive undertaking due to changes in technology goals and practical challenges on the ground. In 2021, Samsung Electronics announced a plan to build a semiconductor fabrication plant in Taylor with an estimated cost of around $17 billion. The initial objective was clear: manufacture advanced 4-nanometer chips and begin production within a few years. Soon after, the global demand for artificial intelligence computing increased rapidly. This shifted the industry's focus toward more advanced chips, particularly in the 2-nanometer range. Samsung adjusted its plan to stay competitive. However, this was not a simple upgrade. Moving from 4-nanometer to 2-nanometer technology required major changes in equipment, design, and manufacturing processes. As a result, the cost of the project expanded significantly, reaching close to $50 billion before production had even begun. The construction phase itself introduced several technical challenges. The ground conditions in Texas were not naturally suitable for a semiconductor facility. Chip manufacturing requires an extremely stable environment, where even minor vibrations can affect production. To address this, Samsung had to create a reinforced foundation using thousands of deep concrete shafts. This structure acts as a stable base that isolates the facility from ground movement. Power supply was another concern. Semiconductor fabrication plants cannot tolerate interruptions even for a short period. The local power grid in Texas has a history of instability under certain conditions. To reduce risk, Samsung had to invest in additional infrastructure to ensure a consistent and uninterrupted power supply within the facility. Water usage is also critical in chip manufacturing. The Taylor facility is expected to require around 15 million gallons of water per day. This is significantly higher than the consumption of the surrounding area. To manage this demand, a dedicated water treatment and recycling system had to be built alongside the factory. Environmental conditions, such as air quality, also required careful control. Semiconductor production depends on extremely clean environments with tightly regulated humidity and chemical composition. Local conditions in Texas meant that advanced filtration and control systems were necessary to maintain the required standards. Despite all these engineering efforts, the more difficult challenge was not physical construction, but manufacturing capability. Producing advanced chips is not just about having the right machines. It depends heavily on process knowledge built over years of experience. This includes understanding how materials behave, how to fine-tune production steps, and how to maintain consistent output quality. Samsung attempted to develop a new manufacturing process while also setting up a new facility and workforce. This created a situation where multiple complex variables were being managed at the same time. As a result, production efficiency, often referred to as yield, did not reach expected levels. At the same time, competitors like TSMC followed a different approach. They developed and stabilized their advanced processes in existing facilities before expanding them to new locations. This reduced uncertainty and allowed for more predictable results. Due to these challenges, some potential customers moved away from Samsung's advanced node offerings. Securing large long-term clients became more difficult, which added pressure to justify the scale of investment. A major development came when Tesla entered into an agreement with Samsung. The deal involves manufacturing future chips that are expected to support Tesla's artificial intelligence systems, including autonomous driving and robotics. The proximity of the Texas facility to Tesla's operations in Austin provides a logistical advantage. However, the timeline for production has extended. Initial expectations have shifted, with full-scale output likely to take several more years to reach maturity. In simple terms, the project highlights the difference between building a facility and successfully operating it at an advanced technological level. Infrastructure can be replicated with enough investment, but manufacturing expertise develops over time through repeated execution and refinement. The outcome of the Taylor facility will depend on whether Samsung can improve its manufacturing processes and achieve stable, high-quality output. The partnership with Tesla may provide the necessary demand and time to reach that stage, but the final result remains uncertain.